Okay, so we're going to continue talking about the ecology of populations with part 3 of the lectures. So again, remember the basics that we talked about in the previous first two parts, distribution of populations, how populations grow, those things we call limiting factors that help control them. If limiting factors are removed, you get that exponential growth, and then what logistic growth looks like. And as we talk about populations, we keep in mind what type of survivorship curve does a population have, type 1, type 2, type 3. So ecologists take all this information, they put it together, and then one more piece of information they add to the picture is this thing called the reproductive strategy. Now, I want to preface this with let's call them the ends of the spectrum of reproductive strategies. You have an R strategist, and on the other side you have a K strategist. But there are a lot of species that fit somewhere in between. Most species fit somewhere in between. But when we look at reproduction, R strategists are also known as opportunistic species. These tend to be small, they have a short lifespan, they produce a lot of offspring. I mean, hundreds, thousands, millions of offspring. There tends to be zero parental care, and then they die. But they've left behind a couple million offspring, and hopefully a few of them survive. Now, generally, our strategists have a type 3 survivorship curve. Okay, so remember type 3. I can write type 3. They have a type 3 survivorship curve. Short lifespan, lots of offspring, etc., etc. Those two tend to fit together. Our strategist, type 3 survivorship curve. The exact opposite end of the spectrum are what we call K strategists. These individuals tend to be very big. They live a long time. It takes years for them to grow and mature. When they have offspring, it's usually only a couple, and then they give a lot of parental care to the offspring. They might, like Mama Bear here, she only has 2 cubs. She's going to take care of those cubs for many, many years until they're mature enough to survive on their own. Her whole reproductive potential might be 4 offspring in her entire life as a mother bear. Most K strategists fit on what we call the type 1 survivorship curve. So type 3 survivorship tends to go with R strategists. Type 1 survivorship tends to go with K strategists. Now type 2 survivorship generally falls somewhere in the middle here. But again, think about common things you guys see all the time. You walked past an oak tree today. Well, an oak tree is a big organism. It lives a long time, takes years to mature. So all those features say, well, that's probably a type 1 survivorship K strategist. But the oak tree produces a lot of offspring. I mean, every acorn is a baby. And some oaks produce tens of thousands of acorns every year. There's absolutely no parental care given to their offspring, and most of the offspring don't even survive. So then that maybe would throw us to type 3. So that's why I want you guys to keep in mind R and K are opposite ends of the spectrum. Our oak tree, let's make a little oak tree. There's the oak tree growing. That tends to fit, when we talk about reproductive strategy, that tends to fit in the middle here versus being a K or an R strategist. Okay, so what we do with this information is we use it to predict population growth. What's going to happen in the future? So deer, rabbits, pheasant, bluegill, corn, beans, dandelions, etc. They all follow these general principles of ecology. So now let's apply this to us, to our population as a human population. So there's a thing called the World Population Clock. You guys can jump to that website, or let me pull one up here for you. And what we want to do is look at what's going on with the human population. How do we fit into this picture? So this is the United States Census clock that shows how our population is growing and expanding and getting larger and larger. But you notice it's not growing real fast. But let's scoot this over and look at the world. Notice how fast the world's growing. So while the U.S. population is just slowly increasing, the world population is growing rapidly. It's growing at 3 people per second, roughly. Okay, so here's the average information down in the bottom corner here. In general, we have about a birth every 7 seconds. We have a death about every 12 seconds. This is averaging. We have natural disasters. Unfortunately, lots of people die in a short period of time. But then hopefully we go days, weeks, months without deaths. Again, this is averaging. So we're looking at 1 death every 12 seconds, 1 birth every 7 seconds. In the U.S., we have an international migrant coming in every 32 seconds. So we gain roughly 1 person every 12 seconds in the United States. So let's check this out. Down here, select a date. Where will the population of the U.S. be? Or what was the population of the U.S. back in January of 2017? Let's go January 1st. 324,309,000. What was it back in they're only going back to 2010. Back in 2010, if we go to January, or let's just do April 1st, 2010, we're at 308,000. Okay, so the key is looking at how fast our population is growing, but more importantly, where they're at and where they're going to go. Okay, so here's our U.S. population September 6, 2017, 325 million. Okay, so the concern is what's happening in the U.S. with our population, but also we have to focus on what's happening globally. We can't just say, oh, let's ignore the rest of the world. What their population is doing impacts us dramatically. We're all connected to the same planet, so we need to pay attention to the world population. So what we're looking at with world population is in the next, let me put a box up here so I can write it in here. In the next 20 to 30 years, we're expecting the human population to reach 8 to 10 billion people on Earth. So the concern is, what's the carrying capacity of the Earth? We have no way to know. We have no way to predict what the carrying capacity is or measure that for the entire planet. I can tell you the carrying capacity of an acre of farm ground in Illinois, but how many acres do we have? Is it guaranteed productivity, etc.? It's a very, very difficult piece of information to obtain, and that's what really scares ecologists. Humans are growing, our population, the human population, is growing exponentially. We did the lag, and then boom, advances in science and technology allowed us to expand. 7 billion people right now on the planet. Are we going to overshoot carrying capacity? Is that red line, is that the Earth's carrying capacity? And if we overshoot, then what kind of crash are we going to see? And when the crash happens, it's going to happen pretty quick. It's not going to be this slow trickling. So the challenge is, instead of overshooting, can we figure out how to level off at carrying capacity? Okay, so remember that clock, the world population clock and the U.S. population clock, and the factors that contribute to growth of a population: births and deaths. When we look at the big global population, how many babies are being born, how many people are dying? Those are the 2 variables to focus on. As we extend lifespan, fewer people are dying. We're living longer. That's leading to a big growth in population. Okay, so here's our projected. The bulk of population growth is expected to come from less developed countries. India, China, most of the countries in Africa, most of the countries in Central and South America, Eastern Europe, etc. That's where the bulk of the population is, and that's where the bulk of the growth will come from. US and developed countries, we're not expecting a huge amount of growth from us. But we still have to be aware of what we're doing in the big picture of population growth and resource consumption. Even though we have a small population, we still impact the entire planet. And when we talk about United States or developed countries. So we look often at age structure diagrams to help look at and determine population growth. If you have a large base of reproductive females, or reproductive individuals, and then you see a bunch of little ones coming up, you know your population is going to grow in the future. Because right here, this reproductive category, that's pretty big. And even if we said, let's only have one child to replace ourselves, the population is still going to grow. It's not going to grow as rapidly as it would if I said, oh, I'm going to have 5 kids, but we're still going to grow our population because we're a type 1 survivorship species. We live a long time. We're not going to die as soon as we reproduce. We're going to see children and grandchildren, and maybe even great-grandchildren. So age structure diagrams play a big role in helping us predict population growth. Now, world leaders get together, and developing countries sometimes point fingers at developing nations and say, quit having so many babies, you're stressing the planet, etc. Here's where we have no room to talk. Yes, the U.S. has 330 million people, approximately, but our environmental impact is massive. The environmental impact of a more developed country, MDC, citizen, is approximately 20 times greater than that of a less developed country's citizens. So yeah, we have a smaller population, but we consume the bulk of the world's resources. We consume the majority of paper, fossil fuels, metals, etc. We produce a huge amount of waste, hazardous waste production from developing countries. So while we may not have a huge population, we're stressing the carrying capacity of this planet beyond belief. The entire planet can't live the same lifestyle as somebody from a more developed country. And I know and understand and recognize a lot of people in developed countries struggle. They struggle. They struggle to make enough money. They struggle to have amenities. Our struggles, for the most part, are nothing compared to what developing countries deal with. I get it. It is very tough. I'm not trying to downplay that. But go to a developing country and look at how most people live. A lot of them make $5 a day. They don't have a car. They don't have a cell phone. They don't have a TV. They live in a very simple house. Maybe they don't even have plumbing and electricity. There's few people in the U.S. that do not have plumbing or electricity. There are those that do have houses where they don't have those resources. That is the exception to the rule in our country. So we want to keep that in mind. How do we decrease our environmental impact while we're asking those countries, those developing countries, to decrease their population growth? We both need to work on it. It's not, oh, just quit having kids and everything's fine. No, we need to decrease our consumption and make a huge difference in how we treat the planet. That will make a much bigger impact than decreasing the population. So both sides need to work together, but we do need to recognize we have a huge responsibility as a developed country, all developed countries, not just the U.S., but all the developed countries. Okay, so in the last lecture, it's going to be a short one, we're just going to talk briefly about some of the different things we can do, some of the different ideas, and maybe come up with some possible solutions.